Hello everyone. Today we will be learning about structural elements. I am Dr. Atrayee Bandyopadhyay, Assistant Professor, Department of Civil Engineering, Haldia Institute of Technology. Let us proceed to the topic now. Okay. These are the list of contents. That is, we will learn first about what is structural element, then the different type of support conditions, different type of beams. That is one of the structural element. Different type of loads, shear force, and bending moment. Okay. Now let us proceed to structural elements. Now, first we need to learn that what is a structural element. The complex structures, that is the building and all, are mainly broken into simpler components that are called structural elements. Why do we do this? Because the structural elements helps us to analyze a bigger and complex structure, that is building and whatever the structure may be. To make it easier to analyze a structure that is that much of a complex, we divide the building into elemental part, that is called structural elements. These elements mainly resist forces and moments, ensuring stability and support for the building or the structure. Some examples of structural elements are beams, columns, slabs, foundation, structural walls, trusses, staircases, load-bearing walls, etc. But we have to keep in mind that non-load bearing walls, doors, and windows, these are not included as structural elements. The structural elements are only those parts that bear loads. Okay. The key features of structural element is each element has a specific purpose and is not further subdivided. That is, beam and columns are not more divided into smaller parts. It itself is a structural element. Mainly, it can be categorized into line elements, that is beams, columns, slabs, cables. These type of elements are in line form, and that is called line elements. The elements that are as structure elements that are of a surface type, that are called surface elements, like walls, slabs, shells, etc. Freeform elements is the another one. It is nothing but the unique or irregular shapes that are considered as structural elements are known as freeform elements. The purpose and benefits of considering structural element is the structural elements help, as I told, analyze and understand the building behavior. To understand the behavior of a structural complex structure, that is like building and all, what we do, we understand the behavior of the structural element, that is of individual beam and column. That helps us to understand the behavior of the whole structure. Okay, so from part to whole, we try to understand. We try to analyze the parts, that is the structural elements, that is beams and columns, which helps in a longer run to understand the whole structure. Okay, this enables engineers to design safe and efficient structures. Okay, let us proceed now. Different type of support conditions. For that, we need to know what is a support condition. A building or structure requires a structural support to provide the necessary strength and rigidity to resist internal forces caused by gravity and lateral forces from wind and earthquake and guide them safely to the ground. That is, the structural element that we are studying or analyzing need to have the strength or rigidity to resist the internal forces that is caused by what? Gravity. It may be the gravitational force, the lateral force, or maybe the wind and earthquake force, or maybe the dead load, the live load. Whatever the type of load that is applied on the structure, it generates internal forces in the structure, that is in the structural elements, from where the structural element is resting on the ends or in the middle, wherever it may rest. That resting part where the structural element is joined with one with another, that part is known as supports, and these support generates reaction to the forces that are applied on the structural part. So for applied forces, these supports generate reactions. Okay, and these support generate reactions and provides the necessary strength and rigidity to resist the internal forces. Okay, so the actions of external loads and buildings cause internal forces in building support structures, which can be found at the end or any intermediate point along a structural member or constituent part of a building. These supports are referred to as connections, joints, or restraints. In construction and engineering, the basic idealized support structures types are categorized below by the type of deflection they constitute, which are roller support, pin support, and fixed support. That means the support are generally categorized with the thing that how much deflection or which direction the deflection are being constrained. That is, each support is constraining movement in some few directions, and those directions are or deflections. The constant in the deflection denotes the type of the support, that is roller support, pin support, and fixed support. Now, what is the roller support? The roller support is that support which allows the structure or the support to move horizontally. Okay, you can see in the image there are two wheels under the support. That is the significance, that is the support can move horizontally, but it is restrained in the vertical movement. That is, this support cannot move vertically but can move horizontally. Similarly, the element that is supported on that support can also rotate. So, in this support, 2 degrees of freedom is allowed. That is, the support can move horizontally and it allows rotational movement. Therefore, in this support, 2 direction is allowed to have movement, that is the horizontal and the rotational. And we all know when a support have a fixed some number of direction where movement is allowed, that number is known as the degree of freedom of that support. That is, degree of freedom is nothing but the movement in the directions that are allowed is called degree of freedom. That is, the support or the element has freedom to move in those directions. That is, for this support, the degree of freedom is 2. That is, the support can move horizontally as well as it can also have the rotational movement. Okay. So, for this roller support, degree of freedom is 2. But we have to keep in mind that this roller support cannot move horizontally. It is restrained from the in the vertically. So it is restrained in the vertical direction movement. So we also know that where it is restrained, reaction generates. So for roller support, vertical movement is restraining. So reaction is generated in the vertical direction. Maybe it's upward, maybe it's downward, but the reaction will generate in the vertical direction, as movement in the vertical direction is restrained for roller support. Okay. It is mainly used in a bridge where one side is pinned or hinged and the other side is roller support, because due to thermal expansion or contraction, bridges generally expand or contract a little bit due to weathers. So, to allow the bridge to have to avoid damage, the end of one end is pinned and other end is roller supported. That is, the slight movement due to the thermal expansion contraction of the bridge is allowed. Okay, so horizontal movement is allowed. That is why in the other end, a roller support is provided. Example of roller support is rubber bearing, rocker, or a set of gears allowing a limited amount of lateral movement. Let us move to the next support condition, that is pinned or hinged. This support has the ability to apply force to a member in any direction, preventing translation of movement and relative displacement of the member's ends in all directions, but it cannot prevent rotational movement. That is, for pinned and hinge support, you can see the wheels that were in the previous support, that is roller support, is not here. That means in pinned or hinge support, horizontal movement is restricted. Vertical movement is also restricted, but rotational movement is allowed. That means this pinned or hinge support have only 1 degree of freedom, that is in the rotational direction. Okay, but not in the horizontal and not in the vertical. So here, where will be the reaction forces? As the horizontal movement and vertical movement is restrained, therefore reaction forces will be on those two sides, that is in the horizontal direction and in the vertical direction. So for pinned support, reaction will be on vertical and horizontal, and degree of freedom will be only in the rotational part. Okay. It is also commonly seen in the trusses. Now for fixed support. For fixed support, the name already signifies the meaning of it, that the support is totally fixed. Neither horizontal nor vertical, neither rotational. No movement is allowed in fixed support. And we all know where there is restraint, there is reaction. That means for fixed support, horizontal side will have reaction, vertically it will have reaction, and for the restraining of the rotational, a moment will also be there in the fixed support. Therefore, fixed support has degree of freedom 0. That is, no movement is allowed. And degree of freedom is 0, but reaction is in all the three sense. That is horizontal, vertical, as well as rotational. That is moment. Okay. Now, this is a chart where we can see the different type of supports and their reactions. That is, for roller support, we can see simple figure that is denoted here, which allow movement is in the horizontal, yes, vertical, no, rotation, yes. And where there is movement, there is no reaction. Where there is no movement, there is reaction. That is, in the vertical, there is no movement, so reaction is in the vertical. Like seen in the reaction, it may be upward, it may be downward, but the direction will be in the vertical. So number of reaction will be 1. Now for pinned or hinged support, we can see horizontal movement no, vertical movement no, only rotational is allowed. Therefore, reaction will be in the vertical yes, in the horizontal yes, and rotation no. That is, direction for reaction is horizontally, it may be right side, it may be from the left side, vertically it may be upward, it may be downward. So the total number of reaction is 2. One is horizontal, one is vertical. And for fixed support, there is no movement at all. That means reaction will be in all 3 directions. That is horizontal, vertical as well as rotational. So there will be 3 number of reactions. Okay. Now for beams, that is the structural element, one of the line element. Okay. What is a beam? It is nothing but a critical structural element in construction and engineering that provides a safe and effective load path to distribute weight to the building's foundation. That is, a beam is a line element, structural element that resists loads by bending. When a load is applied, it bends. Beam bends. And when a beam bends, what happens? The upper side of the beam compresses and the lower side is in tension. That is why beam needs reinforcement to bear the load that is in the tension part. Okay. As beam is generally made of concrete, concrete is not good in performance in the tension part. So to resist this tension, in beam, loads are provided in the bottom part. Okay, mainly. In some cases, beams can have also doubly reinforced cases. Beams can be reinforcement can be on other parts also, but main bars are on the lower side of the beam to resist the tension part. Okay. So beam is consisted of reinforcement, which consisted of main bars, that is the load carrying part of the beam in the tension zone. Support bar located at the top of the beam to hold the stirrups. What are the stirrups? Stirrups is a counteract shear is provided to counteract shear forces and shear stresses. Okay. The purpose of reinforcement we already have discussed, that is ensure safety, that is distribute weight and withstand a wide range of external loads. Okay. Now, we know what is a beam, but what are the types of beam? Mainly, beams are classified according to their support types. That is simply supported beam, continuous beam, fixed beam, overhanging beam, cantilever beam, propped cantilever beam. Okay, these are the main few types of beams that are classified based on support conditions. Other than that, a beam can also be classified as statically determinate or statically indeterminate. Okay, the beam is classified as statically determinate when the reactions of the beam can be determined solely by using the equations of static equilibrium. The equation of static equilibrium is nothing but the 3 equations, 3 generalized equations, that is all the in equilibrium condition of a structure, all the forces along x-axis results to 0, or or all the forces along y-axis is results to 0, and all the moments along z-axis results to 0. That is summation of fx equals to y, summation of fy equals to y, and summation of mz equals to summation of fx equals to 0, summation of fy equals to 0, and summation of mz equals to 0. That is the equation of static equilibrium are these 3 equations. If the reactions are generated in the beam and the supports can be easily determined with these 3 equations, then it is known as statically determinate. On the other hand, a beam is considered statically indeterminate when the equations of static equilibrium alone are not sufficient to determine its reactions. Okay, let us go to the beams classification of beams by the support types. First is simply supported beam. These beams have supports at both ends that are versatile in terms of the structures they can be used with. They allow for free rotation at the ends, as one end has mainly pinned and other end has roller. So in both type of supports, we know that rotation is allowed. That means in both the supports there is no moment resistance. Okay, these type of beams are known as simply supported beam. Now next is continuous beams. These have 2 or more vertical supports that reinforce the beam, making them more economical compared to other beams. That is, one is pinned and the other 2 is roller. Okay, These type of beams are known as continuous beam. It has continuous supports and in between there are span. Next is fixed beam. Then as the name denotes, these beams are fixed on both ends with supports and do not allow for bending, moment production or vertical movement or rotation. These are commonly used in trusses and similar structures. This type of fixed beam have both the ends in fixed support. That is, both sides will generate three reactions. Okay. Now overhanging beam. As the name suggests, these are supports at two areas, typically at one end and in the middle of the beam, but are not supported at the end. That is, in the end, there is a part that is hanging. That is why this type of beam is known as overhanging beam. Okay. That is nothing but a simply supported portion and another overhanging portion. This whole section that is known as overhanging beam. The unsupported overhanging section extend beyond the wall or columns, and this is combination of a simply supported and a cantilever beam. Now we will know what is a cantilever beam. Okay. These beams are free hanging at one end and fixed at the other. They are capable of carrying load with both bending moment and shear stress and are typically used in bridge truss or similar structures. One example we can see easily that if you know a veranda of any house, you can see in the community also anywhere that some houses have veranda extended from the wall, which doesn't have any support in the underneath but hanging from the wall. Those verandas have the beam in the bottom. That type of beam is known as cantilever beam. That is only supported in one end and hanging from that. That is like this. It will be hanging from the support. It will be hanging like this. Okay. And if the beam is hanging like this, in here there is no support. Only this side have support. Okay. So this side has support and the beam is hanging there as shown in the picture. That type of beam is known as cantilever beam. But you know, keep this mind that cantilever beam, when load is applied, what will happen? If this is a support condition and this is the beam and load is applied, what will happen? It will bend like this. So for this cantilever beam, if the load is applied, then what will happen? This side will bend and this side will bend like this. So what will happen if it is bent like this, then this side is under tension and this is under compression. So for cantilever beam, the main bars are provided in the upper side, as this side is taking the tension and this side is taking the compression. So cantilever beam has the opposite of normal beam for reinforcement structure. Okay. The fixed end is typically attached to a column or wall and the tension zone is at the top of the beam while the compression is at the bottom. Okay. Now propped cantilever. It is nothing but just a different type of cantilever which have a pinned support at the end. Okay. A propped cantilever is a structural configuration that combines the characteristics of both a cantilever beam and a simply supported beam. It consists of a beam that extends freely from one end like a cantilever and supports at its free end by an external support like a simply supported beam, that is a pin joint. This combination of the cantilever portion and the support from the props allowed the propped cantilever to handle different type of loading scenarios and offers advantages in structural design, especially in situations where longer span or higher load capacities are required. Okay, mainly such as bridge trusses or similar structures. Now we have an idea about what the types of beams are. Now what will these beams do? These beams will sustain load. So we need to know what type of loadings are there. Okay. A beam is normally horizontal and the loads acting on the beam are generally vertical. Generally. The following are the important types of loads that can act on a beam. That is concentrated or point load, uniformly distributed load, uniformly varying load, externally applied moment, and also eccentric load. Now let us go to the concentrated or point load. A concentrated load is defined as a force that is assumed to act at a single point, although in reality it is spread over a small area in practice. That is, concentrated load is nothing but the load when we consider it is acting at a point. Maybe it is a large area but is acting at a point that is considered here. This load that is acting at a point is known as concentrated or point load. Now the lower side there is a picture of concentrated load, that P, it is showed by an arrow. The P load showed by an arrow is acting on that point where the arrow touches the element, that is beam element. This is an example of concentrated load, okay, on a simply supported beam. Now uniformly distributed load. A uniformly distributed load, generally known as UDL, is a type of load that is evenly spread over the entire length of beam, ensuring a uniform rate of loading, that is as W per unit length, as depicted in the figure below. This right side figure. Okay, like this is a simply supported beam where there is a uniformly distributed load with the intensity omega Newton per meter. Okay. The loading rate is typically expressed as omega Newton per meter run. In calculation analysis, this load is represented as UDL. Okay. So what is the property of this load? That the intensity of the load will be equal throughout the section of the beam. Okay. Throughout the beam length, from the left side to the right side, anywhere you point, the intensity will be same for uniformly distributed load. That is why it is called uniformly distributed. It is not ununiform. It is uniformly distributed load. Okay. To simplify the numerical problem solving, that is using this uniformly distributed load, it is generally converted into a single point load. That is, it is assumed that the whole span, that is the uniform distributed load is acting on, is considered to be acting on for the calculation purpose, that it is acting on the midpoint of the span, where the uniformly distributed load is converted into a point load. How it is converted? The intensity, that is omega Newton per meter, multiplied by the total length of the span. That is, you can assume the length of the beam is 1 meter or 5 meter. So the whole load will be what? Omega Newton per meter into 5 meter, that is 5 omega. The whole load is 5 omega. Okay, then it is considered that 5 omega load, that is the whole load throughout the section, is acting on the midpoint of the load. Okay. This equivalent point load helps streamline the analysis and provides a more manageable representation of the load distribution along the beam. So uniformly distributed load, we know what it is, and for analysis purpose, what we convert it into. We also learned that. Okay. The next analysis steps we will learn in some other day. Now let us proceed to the next type of load. That is uniformly varying load. A uniformly varying load, generally known as UVL, is the type of load distribution across a beam where the rate of loading changes gradually from one point to another, as illustrated in the figure below. In this configuration, the load starts with 0 at one end and increases uniformly towards the other end, like forming a triangle load pattern. Uniformly distributed load, what we learned? We learned that the intensity of the load is equal throughout the span. But for uniformly varying load, it starts at 0 and it ends at some value where the rate of increment is equal. That is, it does not increase high, then increasing low, then increasing high. No. First, it will start at 0 and the end it will have some value maximum, and in between the loading rate, that is increasing. The rate of increment is also considered. Okay. Uniformly. Okay. So the rate of change of varying load is uniform for uniformly varying load. Okay. When solving numerical problems involving UVL, the load type, this type of load for total load is equal to the area of the triangular shape. For simplification, this total load is assumed to act at the center of the gravity of the triangle. We know that the gravity of the triangle is at 1/3 of the apex. So, for simplification, this total load is assumed to act at the center of the gravity of the triangle, that is CG, which is located at the distance of 2/3 of the total length of the beam from the left hand side. Okay, and from the right hand side, you can see that is 1/3 of the total length. This simplification helps in analyzing the beam's response to the varying load in a manageable manner. Similarly, just like UDL, we will also convert the load calculation in UVL also. Okay, but it will act at the 1/3 or from the right side, or from the left side, if you consider it at the 2/3 of the total length of the triangle, that is the length of the beam. Next one is externally applied moment. Now, till now, we were saying that the type of loading is loads, that is vertical load or whatever load it is, that is type of loading is directly loaded. But what if the load is in a manner of twisting? That is, the load is applied at a point and it is rotational. Then it will considered as externally applied moment. So like this, if you if you take a screwdriver and try to rotate at a point, okay, what will happen? Moment will generate. An externally applied moment refers to a twisting force that is externally imposed on a structural member such as beam, column or shaft. This moment acts perpendicular to the axis of the member vertical axis of the member and cause it to undergo rotational deformation. Okay, the applied moment can be either clockwise or counterclockwise depending on the direction of the twisting force. In the figure below, the simply supported beam is subjected to a clockwise moment of m kilonewton meter at point A. Okay, this is a simple example of external moment in this simply supported beam. Now next is eccentric load. The eccentric word is already signifies that the load that is applied at a point is not directly applying at that point, rather than it is applying at a distance to the point of acting. So if an eccentric load is applied to the beam, it must be converted into a couple or force depending on the situation. Like in the example in the below, we can see the 10 kilonewton load operating at a distance of 0.1 meter. That is, this is the 10 kilonewton load where the arrow is there, and the point of acting of the load is 0.1 meter at 0.1 meter distance from the actual load that is applied. Okay. So what will happen? We will consider it to a force and a couple. What will happen? The couple will be, force is 10 kilonewton. It is already acting in that point only, and for the eccentric part, that is the distance, that is 0.1 meter, there will be a couple that is of 0.1 multiplied by 10, that is 1 kilonewton meter. Okay, so the 10 kilonewton load is converted, eccentric load with a distance of 0.1 meter is converted into a directly applying load 10 kilonewton and the couple, that is moment of 1 kilonewton meter. Okay, similarly, if there is a load that is neither horizontal nor vertical and at an angle of some value, like that is example here, that is 20 kilonewton load at an angle of 45 degree, what will happen? What will happen? It can be analyzed using the component, the resolution of component for this load, that is 20 kilonewton and at an angle 45 degree. So the horizontal component will be 20 cos 45 degree and the vertical component will be 20 sin 45 degree. Now easily these things can be resolved, that is vertical forces, horizontal forces and a moment. Okay. Now we have already learned about the beam, their support conditions, what type of loading a beam can handle or it can experience. So when a beam is loaded, what happens? Shear force is generated in that beam. Now what is shear force? Shear force is a structural element. In a structural element such as beam or column refers to the total transverse force acting parallel to the cross-section area of the element. Okay, at any section along the length of the structural member, the shear force represents the algebraic sum of the external forces and reaction on one side of the section. That is, if a section is considered on either side, either left side or the right side, the total sum of the external forces and the reactions are considered, and the algebraic sum of that reactions and the forces represents the shear force. Okay, it is a measure of the internal resistance of the member to the applied loads that tend to cause it to slide or deform laterally. In short, shear force represents the transverse forces acting on a structural element, while bending moment measures the moment or torque acting on the element due to external forces, leading to bending or curvature of the members. Okay, similarly, bending moment is what? Nothing but it is in a structural element is refers to the moment of torque acting on the element due to external forces. At any section along the length of the structural member, the bending moment represents the algebraic sum of the moments of all the external forces and reactions on one side of the section. Similarly, like shear force analysis also, if a section is considered for a beam, on each side, either right or left, which side you may consider, in each side of the section, if you consider all the forces and their moments, the sum of the forces and the moments will result in the bending moment that the beam is experiencing. Okay. In summary, the shear force is nothing but that it represents the transverse forces acting on the structural element, while bending moment measures the moment of or torque acting on the element due to external forces, leading to the bending or curvature of the member. Both shear force and bending moment are very essential parameter in the analysis and design of structures to ensure the stability and safety under various loading conditions. For shear force, there are few sign conventions used to calculate this type of load and moments and shear forces in a structure while analyzing it. And to analyze this in a better way, generally some sign conventions are assumed for both shear force and moment also. So for shear force, let us learn that. For positive shear force, mainly what is considered as positive shear force. A shear force is considered positive when it causes a downward force on the left side of the section that is being analyzed. It implies that the left side of the section tends to move downward with respect to the right side. Okay, so if the left side move downwards, it is called positive shear force, and if it is downward, then what is the right side, what is happening, it is going upward. So if the right side is going upwards, that will also be considered as positive shear force. Similarly, negative shear force is just the opposite. If the left side is going upward and the right side is the downward, then it will be considered as negative shear force. Okay. Next, for bending moment. For positive bending moment, it is considered positive when it causes a structure member to bend in a concave upward way. Okay, this means that the top of the beam is in compression and the bottom is in tension. Okay, like this. Like if it is bending like this, that is sagging bending moment. It is also called sagging bending moment. Okay, and this is also called positive bending moment. Like if this side the moment is like this, it is bending like this, and this side is bending like this, then this type of bending moment is called positive bending moment. Similarly, if the bending moment is causing this, and this side it is causing this, and it will make the beam like this hogging, it is called negative bending moment. Okay, so for negative bending moment, a bending moment is considered negative when it causes a structural member to bend in a concave downward direction. This means that the top of the beam is in tension and the bottom is in compression. Okay, in other words, the bending moment creates hogging or upward bending in the beam. Hogging or upward bending in the beam. Okay, so these are the sign conventions that is considered for uh, shear force as well as bending moments. Okay. Now, what do we learn from these things? These are the basic knowledge that is required for proceeding in analyzing a structure. That is, if you start to analyze a structure, you need to know the basic knowledge that is regarding the beams, the forces that is acting on a beam, the beam that is resting on the supports. If you don't know these things, you will not be able to analyze the structure further, because if you don't have the idea of the basic things, how will you proceed to the higher level? So by studying this, we have gone a step further towards the understanding of the structural analysis, which in future will help us to analyze and make safe structures. Okay, so let us see on our next meeting what we can learn from the further knowledge. Okay, thank you everyone. Have a good day.